So today what we're going to be doing, we're going to be going through the CSEC January paper, and this is for 2020. This is a paper that they did earlier on in the year. All right, so this is how the exam structure is now these days. And you fill out all of these information. So always read through the instructions. It has 2 sections. Section 1 has 7 questions. Section 2 has 3. We do everything in the paper, and it says, write your answers in the spaces provided in the booklet, which we have right here. All workings must be shown clearly, so always show all your working. A list of formulas is provided on page 4, which is the next page. And if you need to rewrite any answer and there's not enough space, then you need to ask for an extra booklet. And look at what you're required to use. You're required to use an electronic calculator and a geometry set. These are the formula sheet, but this is easy stuff to remember out of our head. And so let's do it. So question 1. All right, it's always good to start with the easiest question on the paper, which is question 1. And this question says, write, well, using a calculator or otherwise, calculate 4.5 times 1/3 minus 1 1/4. So this is just fractions, very easy question to do fractions. All right, now we know BODMAS, so we have to work out multiplication first and then we do the subtraction. I like to convert everything to a mixed number. All right, when I'm dealing with improper, I like to convert to a mixed number. So 4 and 1/5, you multiply 5 times 4 to get 20 and add it to 1. So this is really 21/5. This is what we have, 21/5, and it's being multiplied by 1/3. All right. And then after we work out this, I put a bracket around it. We're going to subtract 1 and 1/4. But 1 and 1/4 is 5/4. All right. So let's work this out now. When we work it out, what we're going to be getting is 21 over, because when you're multiplying 2 fractions, you multiply across their numerator. So we get 21/5 times 3 is 15. And then we're going to be subtracting 5/4. So subtracting 5/4, we cannot do that like that, right? Because they have different denominators. So we have to make them have one common denominator by finding the LCM. So the LCM between the two, which is not 15, don't follow this. The LCM is the lowest common multiple between the two. And that, I would think it's 60. So we're going to say 15 into 60, that goes 4 times. So we say 4 times 21. 4 times 21, that is 84. That's 84 minus 4 into 60 goes 15 times. So that's 15. All right, 15 times 5 is 75. Then 84 minus 75 is 9. So the final answer that we're getting is 84 minus 75, which is 9/60. It did not say the right answer in its lowest term, but you could simplify if you want to say 9/60. I can simplify this to be, let's check in the calculator, that's 3/20. So the final answer is 3/20. Easy, soft. And if you don't believe it, you can actually work it out in your calculator. All right, always check it in your calculator. 4 1/5 times 1/3. You do that in a calculator. Then you subtract 1 1/4, and you get 3/20. So this is indeed right. So this is the answer. All right. The answer is 3/20. All right, now the second part of the question says to solve this. And this is just division. So whenever you're working fractions like these, what I would always say to do is always simplify the numerator first. So 4 minus 1.25 squared, I would simplify what's the numerator. You just put this in your calculator. So that's 4 minus 1.25 squared. When I put that in my calculator, I'm getting 2.4375. Just put that in your calculator, and that is what you get. And then you divide it by 0.005. When you do that division now, then you get your final answer divided by 0.005, and I'm getting 487.5. 487.5. And that takes care of question I and question II. Soft, easy question. CSEC math is so nice. But that's just the first page, you know, warming up. So now we get to part B. Now part B seems to be a consumer arithmetic question. All right, so let's work out this consumer arithmetic question. This consumer arithmetic question, it says, a stadium currently has a seating capacity of 15,400 seats. All right, so it's 15,400 seats. Calculate the number of people in the stadium when 75% of the seats are occupied. So when the stadium is at full capacity, it's 15,400. Now we need 75% of 15,400. So all we're going to find is 75 over 100 times 15,400. And that will tell us the number of people in the stadium at 75% capacity. So let's work that out. 15,400 multiplied by 75 over 100. So putting this in my calculator, what I'm getting is 11,550. That's 11,550 people are in the stadium. That's what this works out to be. 11,550. That's the answer. All right, we just had to find 75% of the total capacity. All right, now let's go ahead and move on to the next part of the question. It says the stadium is renovated with a new seating capacity, and they increase the amount of seats to 20,790. After the renovation, what will be the percentage increase in the number of seats? So to find the percentage increase in the number of seats, first we need to find how many seats will actually increase by. So let's find how many seats will actually increase by. The increase is, let's find the increase. The increase is equal to, the increase is going to be the difference between this capacity to the original capacity. So the increase is 20,790 minus the original capacity, which was 15,400. That was the original capacity. Now, when you take the difference between the two, that will give you the number of increase in seats. So taking the difference between the two, we're getting The number of increasing seats is 5,390. So that's the number of increased seats. So to find the percentage increase now, the percentage increase is going to be the total number of seats, the total number of increased seats, which is 5,390, divided by the original capacity times 100. Remember, we always multiply by 100 to get the percentage increase. All right, so very easy question. So percentage increase, as you can see, it's equal to, again, percentage increase is the number of increased seats, which is 5,390, divided by the original capacity. And the original capacity of the stadium was 15,400 seats. And then we're going to multiply that by 100. This will give us the percentage increase. So you just go ahead and work that out in your calculator. 5390 divided by 15,400. And I multiply that by 100, and I'm getting a 35% increase. So there's a 35% increase. There's a 35% increase in the number of seats, which is very good. Remember, increase is always relative to the original, all right? So that's why we divide it by the original capacity of the stadium. Very, very easy question. 35% increase in seats. Soft. All right, now let's look at this question now. This is the last part of question 1. It says a neon light flashes 5 times every 10 seconds. It says show that the light flashes 43,200 times in 1 day. Now, there are many ways you can do this. All right, this is a direct variation question. All right, but I'm going to do it the 2 method. So what we can say is that it says a neon light flashes 5 times every 10 seconds. So neon light, so there's 5 flash every 10 seconds. So 5 flash corresponds to every 10 seconds. 5 flash is corresponding to every 10 seconds. All right, to every 10 seconds. 5 flash corresponds every 10 seconds. Sec stands for seconds. So we want to know how many flash is going to correspond to 1 day. Now, how are we going to determine how many seconds make 1 day? To determine how many seconds make 1 day, first and foremost, we know it's 60 seconds make a minute. So 60 seconds makes a minute. And then 60 minutes make an hour. So 60 times 60, that's 3,600 seconds to make an hour. And then we times that by 24. This will give us the amount of seconds that are in a day. All right, so this will give us the amount of seconds in a day. 60 times 60 give us 60 times 60. That's giving us 3,600 seconds in an hour. Then we times it by 24 to say there are 86,400 seconds in 1 day. All right. Now we want to know how many flash will correspond to this. So to do this now, what we do is we do cross multiplication. So if you want to call this unknown x, this unknown x that we're going to find, we're going to realize that x is going to be equal to, when you cross multiply it, you're going to get 10x is equal to 5 times 60 times 60 times 24. So 10x is equal to 5 times 60 times 60 times 24. That's what 10x is equal to. All right, and then when you work this out, you're going to get 10x is going to be, let's work that out. 10x is going to be 5 times 60 times 60 times 24. That's 4 432,000, 432,000. That is 10x. So we divide both sides by 10 now. We're going to divide both sides by 10 to get what is x, where x is the amount of flashes in a day. So when you divide both sides by 10, we get x is equal to 43,200 flashes for the day. All right, so when we divide, we get 43,200 flashes in one day. So this is one way you could do this question. All right, easy, soft. Now let's look at the alternate method, because many persons may not necessarily want to do this question this way. So now what we're going to do is we're going to use direct variation. Direct variation, all right? So what I'm going to do is we're going to call a neon light flash F. We're going to call a neon light flash F. One flash, we're going to call that F. All right, we're going to call one flash F. So I'm not writing that down, but we're calling one flash F. All right, we're calling one flash F. And then what we're going to say is the flash is proportional. Flash is proportional. Flash is proportional to time, and time we're going to use is seconds. So flash is proportional to seconds. All right. And so using direct variation, then that means the F is equal to Ks. F is equal to K, some constant times S. Now, how are we going to find this constant? Now, to find this constant, we're going to look at when 5 flash correspond to every 10 seconds. So we can use this. When F is 5, when F equal 5, we know S is 10. When F equal 5, we know S equal 10. So using that now, we can solve for K. So using that, we're going to get 5 is equal to K times 10. 5 is equal to K times 10. And so if 5 is equal to K times 10, then clearly K equal a half. Clearly K must equal to 0.5. All right. Now the next part that we're trying to find is we want to find how many flash corresponds. We want to find how many flash corresponds to 1 day. So in one day, how many seconds make a day again? In 1 day, we know that, just writing in 1 day in blue, in 1 day, we know that the time is going to be, which is the amount of seconds, is going to be 60 times 60 times 24. That's how many seconds make a day. 60 times 60 times 24. That is how many seconds make 1 day. All right. 60 times 60 times 24. That's 86,400. 86,400. That's how many seconds make 1 day. So now when we're going to find how many flashes is corresponding to 1 day, we're going to say F is equal to K times S. F is equal to K times S. But now K is a half. So F is equal to a half, 0.5, times 86,400. And that will give us how many flashes corresponds in 1 day. When you multiply across these two, you're going to get back the same answer as above, which is 43,200. All right, so any method you want to use is your choice. Easy, soft. All right, a lot of persons are familiar with this method, and so either way is fine. Easy question.